I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Peace! Peace! Amen.
Ladies and gentlemen, welcome to Job Shop USA. My name is Keith and I'm your host. Today, we're getting back on Pearl. Actually, for a long while, I've actually tried to get Pearl back underway, but the shop's busy and I have other things that I need to address. We're set up here turning our finished diameters. This is a rolling gear, and then we have this gear. This is the one that we ground the ID, and we're going to turn this diameter a little bit larger in there. So we're roughing down these diameters right now because we need to put that key in. Then we can go ahead and heat treat this. After we heat treat it, then we'll be tool post grinding these, and we're going to set up this grinding on this land right here between each one of these on the surface grinder. This section from here to the end here, we've roughed this diameter down. Right here is where that gear is going to ride. It's a little bit larger in diameter here. I've got that set up so that it'll compensate for this diameter. This bearing out here has to stay that same diameter. Otherwise, we'd make the whole thing the same diameter. But this will actually be ground to fit a bearing race. The cone part of the race slips on here. All right. And then this is the gear diameter. This is another gear diameter, but this gear rolls and it locks in with the cog that slides back and forth on here. All right, we saw that when we were taking it apart. Now, when you saw, actually, this was roughed out, and you can see how the wheel cutter came in on this diameter. So I came and plunged, and I went across and created both sides of this and that relief at the same time. And then this right here was just done with the wheel cutter coming down and plunging. This is flat, okay, meaning it's flat this way here. But after we grind it, it'll be ground to the diameter of the inside of the sliding cog. Okay, so that's actually a round surface. So the stone to grind this in here is going to be set up with the concave radius preset in the stone. Now with the nice undercut right here, we know that everything's going to slide past the spline here, and you're going to have non-interrupted. And we also have good clean material down in here. So it was pre-set up that this root was never going to be down far enough, but we also have a couple thousandths on this diameter. We're going to grind it just a couple thousandths larger just to take away some of the play that's been over the years. We don't want to take too much out of this because you don't want to. You got four shafts, 5 shafts, depending on the output shaft for the gear feed, and counting that in the gearbox. And you can't have 3 shafts running real sloppy fits and one super tight fit. So you got to have somewhat a matching age of the machine as well. I would say I'm gonna stamp that bullshit. Okay. All right. So this in here. We're gonna finish up, and we're gonna turn the other 3 ends because we're running 2 shafts just in case we scrap one. We want to make sure that we're not going backwards or we're not having to spend the time to go backwards. Been about a week since I was playing with this end, or before a week ago, I had to tear apart the setup and then reset it up, return my center, and that. Refreshing myself with the diameters that I measured, or I left these over the dimensions that we're going to be grinding to. So I snapped the inside of this, and this was basically 1 inch 375 and a half, and this is 380 um 385, I mean. um so we left about 10 thousandths on these diameters here, and it's more than enough, and I just want to be sure. So these three diameters right here are set to those relationships to the bearing, gear, and gear. We're ready to flip this around. Pull our tool bit out of here so we don't knock that. We'll move that one out of the way. Now we got to loosen our dog. We had to machine a dog because we can't remember where we put our dog collection for our lathes. Since we moved over here to the new location, I just haven't found them yet. Keep them moist. We don't really need it in on the live side, but it's not a bad idea to just keep putting it in there, flushing out any dirt. All right, we're ready to go for this side. Okay, this is looking at the end we're going to work on now. So this will be turned to match this one here. This will be like 1 inch 385. And then this diameter here, the bearing and the gear match the same diameter, and that's basically 1 1/8, give or take a half a thousandths or so. And I'm going to turn this to 1 inch 135. Make these reliefs and make sure everything is the right lengths. All right, I'm going to hold this one across here. That way you can see what I'm talking about as far as lengthwise here. The very first thing I'm going to establish The very first thing I'm going to establish is the length of these splines. And just measuring over the end here, I had left, looks like about 48 thousandths on the overall length. I'm already happy with everything on this side here for length and the shoulders and that. So now I can go ahead and bring this up to par, to length. And then from here out this way will be corresponding to that. So I left a little bit extra on the parts that I'm making so that I had enough material in there if I had to shift it a few thousandths one way or the other. The main thing is going to be the load of the two cone bearings on the end, and then those will be set with a thrust on the bearing caps on the end of it. But you got to have everything pretty close in the center, because this gear does slide and engage the two rolling gears on each side here. All right, we got about 47 thousandths to come off of there. And now we know where that's at there. We have set a 0. And now we're going to touch on here, but we want to create a diameter, because I want to know and get my dial set here, because the readout doesn't correspond with today. The readout was it corresponding to the last job I had in there. So everything I had set for this side here on diameters is no longer with us, and I have to reestablish that. This is the first time I've set it up between true centers, so you can see how far off we were just by chucking it on one end and then running the center in the other end. Plus we were hogging. So that's why you see a little bit of run out there. Okay, 1,442. We took another cut there, and we're at 1,425. We're just going to take it on down to 400. Okay. What's nice, we don't have to worry about this finish right now because we're going to be having it oversized and we're going to be doing a grind finish on here. As long as it's smooth and our micrometer doesn't like gall up on it. How rough would that have to be? Okay, we're right down to 1,400, and the dimension we want to match this one here, and this was 1,385. So we're going to go ahead and just take it right on down to that. This will be the last cut on this diameter. Dr. Mason, not feeling good about the country. I'm not feeling Dr. Mason. One 385. Okay, we've got to take some off of this face. We're going to take this face on down um, to that diameter. We're going to get it close. We're going to leave a couple thousandths on here because once we get down in there, then we want to make that relief so deep and so far out from this shoulder here. All right. We got like 40,000 to go on there, so we're going to come in and touch. It should make Here's 10 thousandths off of that face. And we can go straight on in until we get to our 1,385. Right there. We're going to take a quick length measurement here. Okay, 3 inches 36. We got 36 thousandths more to go. We're just going to take it in increments of 10 here. This would be the last one. This is 26 out of that 36, so double check it again. All right, the relief in there, the diameter is 1,342 and 100 thousandths out from the face here. So we're just gonna come in until we got that. Okay. And I'm measuring out my 100 thousandths there because it's not 100 thousandths straight out from that face right there because I have it angled. The back of this tool bit is an angle. All right, and that's what I'm setting is the edge of that angle. So when this is down to diameter, that dimension comes out there right at that dimension. All right, I like that. All right, I think we got 5 thousandths more to take off of this face. Yes, exactly. 5 more thousandths. We come down with one plunge cut. Okay, right there. And we go right on down to our 342. All right, 343, right in there. All right, and these are exactly 3 inches. I'm right there. That diameter, okay, we're all set. Now from this face out to that end and that diameter and that relief there, that's next. Okay, we know that this was 3 inches here and that we could come out like this and get that shoulder and we can get that shoulder right there. So we just double check this one right here and we're within a half a thousandth of that one. So now we can feed this one here this way and they're basically an inch out from each side here. So this is really 4 4 and 4 4 this way here and I got like 410 and 454. So we got some more to come off of here, and of course it depends on exactly how I get a 405. If the tail end of this rubs on the stock here. What I'm saying is I'm on the money. And we know that we need to have about 50 thousandths down off of this one here, and just taking the scale here, and it does look like take the flexible scale. That way we can hold it right in here. And it does look like 150. All right. When we were over here, we know that that was uh, 1 inch right there. Come over here, just kind of touch. We're just eyeballing with the feel here. And yeah, 43.5 thousandths. We're going to work this in the same. We're going to take the space down where it's real close within a couple thousandths. Then we're going to do this diameter, then the relief. Okay, this diameter here is 150. Our readout says 136, so we'll measure it when we get done with this pass. One inch, 137.5. All right, we punch that in, and I think we only wanted that to be just. We're gonna go ahead and take it down to 135, like we did on the other side there. So that should be a thou per side. It's hard to get it right perfectly in line because the camera is 3 foot away from this shot right here. See if I can zoom in a little bit farther with my little control here. I'm losing the clarity here. For a 1,000th cut. I'm saying per side, okay? Okay, I'm not going anywhere. Let's see what we got here. Yeah, it feels pretty smooth. There we go. Okay. Ready to change this out with the other one. So let's swing you right around because the other one's in the surface grinder. All right, and we've got this set up here because this is going to be the setup for grinding the centerpiece in here. And then if we need to touch up on the widths, we'll be able to do that all in this setup right here. And we'll exchange these. This has a set a tension that we can adjust that after it's in place. We can tighten that down so this won't accidentally come out of here, because we will be grinding in this direction because we have the freedom to go over that center there. All right, and we still have goop in the centers there because we've had it fresh over on the other side as well. All right, good to go. We just finished turning everything on this shaft to match the first one we did, within a couple thousands everywhere. We're happy. Before we go and put these keys in we're going to go set up on that now. But I took the stack up here on the old shaft because I wanted to know how much side thrust was really on these rotating or spinning freely gears until this cog comes and shifts into that. And so I was holding the shaft here and I was holding the gear down across here, and I was able to still spin it. Of course, it's dusty and dirty, and there is a little bit of wear in a couple different areas. Okay, I know where this contact's in here. Also, there's two punch marks that are in on these gears, and these were the faces that go towards the cluster. Okay, so these gears are going to want to go back in because they've been running in that position. I do not want to roll them over. This one here you can't roll over, but this one here you want to make sure you don't roll over. So I recognize those. In fact, actually, when I pulled them apart and I looked at them, I knew that was also a mark. And so we're going to put them back together the same way. Now, there's a couple different things that I can do to go ahead and make sure that we have this clearance. And this is the thrust ring right here, and this could be put in the surface grinder and a couple thousands taken off of it. Or if we, there's different areas that you can grind or machine, and you can get the thrust in here. And I was just taking a look at it so that I knew how close it was. And you can't have these gears drifting side to side, and you need them to stay true because they are floating on the shaft, except for when they're engaged with that the cog. Then they're rolling with the shaft, and they're going to engage, run this gear or run this gear down here, and that's how it works. By just shifting back and forth, you've got a high and low on this shaft, and this is the second shaft on the input. That's why we were missing half of our gears. All right, let's go set up on the keyways. Well, we got a mess there. Our dividing head's over there, and I don't even have a place to put this down. Okay, we're going to be doing some switching around here. All right, I just finished that hex there. We're making a nut for a special helm wheel for one of our customers. This has to go over there. Now that's actually coming out. This has got to go over here, but that's got to go over there, and everything's got to get cleaned up. All right, let me get my shit together, and until the next video, get her done.